Have you ever wondered why a heavy person sits closer to the center on a seesaw? The answer lies in moments. A moment is the turning effect of a force about a pivot. To calculate it, multiply the force by the perpendicular distance from the pivot. The formula is moment equals force times perpendicular distance. The SI unit is the Newton meter. Forces can create turning effects in two directions. A clockwise moment turns in the same direction as clock hands. An anticlockwise moment turns the opposite way. When we solve moment problems, we always label which direction each force turns about the pivot. The principle of moments states that for a body in equilibrium, the sum of clockwise moments about any point equals the sum of anticlockwise moments. Look at this balance beam. Both sides produce equal moments, so it stays level. If one side has a larger moment, the beam tips.
Let us solve a simple problem. A 10 Newton force acts 0.4 meters from the pivot on the left. We need to find the unknown force F on the right, which is 0.8 meters from the pivot. By the principle of moments, clockwise moments equal anticlockwise moments. So F times 0.8 equals 10 times 0.4. That gives us F equals 4 divided by 0.8, which is 5 newtons. Now a harder problem with multiple forces. On the left, we have 6 newtons at 0.3 meters and 4 newtons at 0.5 meters from the pivot. On the right, an unknown force F acts at 0.2 meters. First, calculate each anticlockwise moment. 6 times 0.3 is 1.8, and 4 times 0.5 is 2.0. The total anticlockwise moment is 3.8 Newton meters. Setting clockwise equal to anticlockwise, F times 0.2 equals 3.8. So F equals 19 newtons. The most common mistake is using the slanted distance instead of the perpendicular distance. Remember, the distance in the moment formula must always be measured at right angles to the line of action of the force. If the force is at an angle, use D equals L times sine theta to find the perpendicular distance.
Remember, moment equals force times perpendicular distance. For equilibrium, total clockwise moments equal total anti-clockwise moments. Always identify the pivot first, include every force, and check your units are in Newton meters.